Follow the Sun. Presented by Science at NASA. The sun. It inspires songs, warms us, and grows our food. Life on land and in the oceans, the daily weather, and long-term climate patterns happen primarily because of the energy we receive from our closest star. Even tiny variations in that energy can affect the workings of our planet's atmosphere. NASA uses instruments to follow the sun and monitor the amount of solar energy coming to us. The latest instrument to do so, the Total and Spectral Solar Irradiance Sensor, TSIS-1, makes those measurements with unprecedented accuracy. TSIS gathers information from its perch aboard the International Space Station, or the ISS. Flying on the platform that the orbiting laboratory provides has allowed TSIS to continue NASA's 40-year record of tracking the sun's radiant energy, one of the longest and most important climate data records gathered from space. Over the past several decades, Earth's ice mass has diminished, sea levels have risen, drought and precipitation patterns have changed, and growing seasons have shifted. To understand the causes, including human influences, of these changes, and to refine the models used to simulate Earth's climate, researchers must know the amount of incoming solar energy. Peter Paluski, TSIS lead mission scientist, explains, "When there's a balance between incoming energy from the sun and the infrared radiation Earth emits, climate remains steady. An imbalance means energy is either being stored in the system, causing temperature increases, or lost, causing temperature decreases. Energy from the sun makes up half of the balance equation. Even though the measurement record shows that the sun's solar energy output has not had a major influence in recent climate change, that output needs to be monitored continuously. It is arguably the most important variable we need to know to understand climate," says Paluski. "Trying to understand climate without measuring the sun's input is like trying to balance your checkbook without knowing your income." Climate is measured over long time spans, decades to centuries and longer, unlike weather that changes over small time scales. To be able to connect measurements over long time periods, continuity and accuracy are key. TSIS has two sensors. The Total Irradiance Monitor, as its name suggests, measures all of the radiant energy from the sun, and the Spectral Irradiance Monitor measures how that energy is distributed over ultraviolet, visible, and infrared wavelengths. The latter helps scientists understand where in the atmosphere solar energy is being absorbed. For example, TSIS spectral irradiance measurements of the sun's ultraviolet radiation are critical to understanding the ozone layer. Ozone in the stratosphere absorbs ultraviolet light. This heats the stratosphere and drives changes in atmospheric wind flow that can propagate down to the lower atmosphere and impact climate. So many factors influence Earth's climate, says Paluski. We need to continue learning how they all interact. TSIS is helping us characterize the sun's behavior and how Earth's atmosphere responds to the sun. For more science from the International Space Station, go to www.nasa.gov/ISS-science. To continue following our closest star, visit science.nasa.gov.